All right, everybody. This is a short video to try and help you understand how to figure out the velocity of your car if it's traveling along. I just shot a couple short films of a Hot Wheels car that had traveled down a ramp and then it moved on the flat for a while until it struck a wall. And the question is, how do you find the velocity of this car? So let's go ahead and take a look at the film itself. It's fast, to say the least. And so take a look what happens if I hit play. Right? It's almost so fast that you can't even see it, right, as it moves along. So I'm going to go back in the film a little bit to when the car is just appearing on the screen. There it is, and then I'm going to hit my comma key and my period key on the keyboard, which are the two angle brackets, if you remember, in order to step it forward or step it back as I go. So as I'm hitting those, you'll see that this the screen, and every time I hit that key, it steps forward a single frame. Let's take a look at what that video looks like here in the middle. I've got this car that is super blurry. And the reason for that is I filmed this at 30 frames per second. So I didn't film it in high speed like I had done with other videos. I just filmed it at 30 frames per second just because some of you might be filming in that same way. 30 frames per second means that every second, kind of the camera opens up and it takes a picture, and then every 30th of a second, the camera opens up and takes a picture, and then it closes down a 30th of a second later. And in that time that the camera opens up for a 30th of a second and then closes back down again, you're getting motion of the car. So there's a bit of a blur kind of within that frame that you're doing. So it is moving pretty fast along its way. So it's now my goal to look at this picture and to be able to figure out if I can find a place on the car to potentially take note of where that is. Right here in the front, right, as I'm looking at it, I've got a kind of a motion blur at the beginning, but I'm going to take it to maybe the front of where I can see this wheel, because the wheel's kind of shiny. And so I'm going to take it to kind of the front of the shininess here, which if I'm making approximations, this isn't going to be perfect, but I'm going to say that that's at about the 7 centimeter mark, right? And if I move forward one frame, that bit of shininess is now somewhere about 5.5. So it was at the 7 centimeter, and now it's at 5.5, approximately, as I'm working my way into it, right? So I'm going to write those two things down on a piece of paper. I'm going to write 7 centimeters, and I'm going to write 5.5 centimeters down on my handy dandy piece of scratch paper that I have here. So 7 centimeters, 5 centimeters. And what is the duration, the difference between those two in terms of frames? How many frames did that take to go from one to the other? The answer is it took a single frame, and one frame is 1/30th of a second. So if I want to figure out how fast the car is moving kind of before it hits the wall, I can go ahead and use that information. While I'm here, I'm going to go ahead and find out how fast it's moving after it hits the wall also. So I'm going to step forward. There goes the car. It's going to strike the wall here. Boom. And you'll notice that it's already going backwards. So the actual point that it struck the wall might not have even been captured on camera because it happened so fast. So if I was thinking about this here, 1, 2, 3, 4, 5, like there is only one frame that it's touching the wall. It bounced off so darn fast. So if I want to figure out how fast it's moving in reverse, right? So here's reverse. What I need to do is find, kind of the front of the car somewhere, or the wheel if I want to, and I'm going to figure out kind of how far it moves, which is a change in position, and then how many frames that happens. So I'm going to go ahead and start here because that looks like the kind of the front of the car is touching the 2 centimeter mark. So I'm going to write down 2 centimeters on my piece of paper, and then I'm going to go move my advance forward in my frames. 1, 2, 3. It appears that it is now at the 3 centimeter mark, and it took 3 frames to do it, right? Because it was here at the 2, and then 1, 2, 3 frames to do it. All right, good. Based on that information, I'm going to go and use it to calculate the velocity. So I've got my handy dandy whiteboard here so that you can see what I'm talking about. And I'm going to write down a few things, making sure that I know what I'm working on. So first off, the car, when it was moving this way, right, it was at the 7 centimeter mark, and then it moved across and it got to the 5.5 centimeter mark. Those are two different kind of positions, if we want to think about that, right? And a change in position from my starting point here over to my ending point here is going to be a negative, because I was at 7 and now I'm at 5.5. And how much has that changed? Well, I would take my final position, which is 5.5 centimeters, and I'm going to subtract from that my starting position, which is 7 centimeters. And so my change in position, 5.5 minus 7, is 1.5 centimeters, but it's negative. Agreed? So my change in position is a negative 1.5 centimeters. All right. How much time did it take for that to happen? Well, it happened in one frame, right? That's all it took for that to happen, is in one frame. And one frame, each frame happens for 1/30th of a second, right? Because I'm shooting at 30 frames per second, and therefore each frame happens at 1/30th of a second. So that's my amount of time. So I really have everything that I need right now, because I know my change in position. And this here is actually my change in time, if you want to think about it, that, right? So this is my change in time of 1/30th of a second. So to figure out what my velocity is, I'm just going to say my velocity is equal to my change in position divided by my change in time. And my change in position is this negative 1.5 centimeters. But if I want to figure this out in meters, I need to divide by 100 to get there. So negative 1.5 divided by 100 gives me negative 0.015. And this is in meters. I should probably move this part over a little bit so it doesn't get too crowded. All right. So that's in meters, and this is in seconds. So now what I need to do here is take this negative 0.015 meters, and I'm going to divide that, and I need to be careful. I'm going to divide that by this fraction 1/30 seconds. Now, that's not the same as dividing negative 0.15 by 30. That's different. In fact, math-wise, if I do this, because it's a 1/30 on the bottom, it's really multiplying by 30. Now, on a calculator, this works out too, but we need to know how to type something like this in. Some calculators can handle it easily and some cannot. But what I would type on a calculator is I would type in negative 0.015 divided by, and then I put in a parenthesis, again, if my calculator can handle it, 1 divided by 30. And that's what my calculator can handle as it goes. And whatever I get out of that is my velocity. You'll notice that that velocity will be negative, of course. And the reason for that is because the change in position is negative as well. So I've got a negative 0.015 divided by parenthesis 1 divided by 30 end parenthesis. And what I walk away with here is a velocity of negative 0.45. And it's a meters on top and a seconds on the bottom here. So it's going to be meters per second. And that is my final answer as to how fast this is moving, right? And because we're talking about this in terms of the car before it impacts the wall, I would go ahead and say that this is my initial velocity. So my starting velocity is this negative 0.45 meters per second. All right, I'm going to do the exact same thing for this, only thinking about it in terms of the second motion, right? This is after it's hit the wall and it's bounced off, and I want to find out how fast it's moving now. There's a lot of similarities between this for the second collision. So on the second collision, same idea, only now we've got some new positions and we're moving a different direction. We're going to start off at the 2 centimeter mark, and then we're going to slide over here to the 3 centimeter mark. Right? So this is my change in position that's happened now, is just the single centimeter. So my change in position, oops, that's not a good triangle. My change in position is equal to 1 centimeter, which is also equal to 0.01 meters. Well, how much time passed for this one? To go ahead and figure this one out. Well, my change in time this time was 3 frames. And with 3 frames is equal to 1 over 30, excuse me, not 1 over 30, but 3 over 30 seconds, because each frame is 1/30th of a second. So then 3 frames is 3 over 30. So my final velocity, as we were thinking about it before here, is equal to, now it's both positive, a change in position over a change in time, where this time around it is 0.01 meters. And that's going to happen over 3 over 30 seconds, right? Now, do be careful on this. Again, I need to do this, calculator wise. I would do that with parentheses in there, just like I did before, but I'm going to go ahead and type this in. So I've got now a positive 0.01, and I'm dividing by parentheses 3 divided by 30, end parentheses. And you can see what we're going to walk away with here is 0.1 meters per second. That is slower, but it's in the opposite direction, right? So the number up above, actually, let's put in our VI here. I'm erasing things on accident by hitting buttons. There we go. Let's go ahead and scroll up here a little bit. So I've got, I'm putting in my final velocity. I want this to be my final velocity. Got to make sure that all the variables and subscripts are right. So there I have it. I have a negative 0.45 meters per second on the way in, and then it hits the wall, and now it is a positive 0.1 meters per second on the way out. Hopefully that was helpful, and I'll see you in the next one. Adios.